Measures of a spread, 2.6. So if you want to measure the spread or dispersion, we can talk about the standard deviation and variance. What is the standard deviation? So deviation is x minus mu, means how far is your data from the mean value. You know, the mean value for population is mu, and the mean value for sample is x bar. So deviation means how far your data is from the central data or the mean. When we talk about standard deviation, this is the formula. Square root, the standard deviation is sigma is equal to square root of x minus mu power 2, the summation of that. Your data minus the mean value, you add square it, add for every data here, the summation is addition, divided by n. Basically, this will tell you the average, how far is your data from the mean value, the distance, the average distance that your data is spread about the mean value. The same thing when you have a standard deviation for sample, make sure the denominator is n minus 1. Okay, so then let's talk about the variance. So variance is the same, but you power it by 2, sigma power 2. The square root here will cancel. Sigma power 2 is your variance. Summation of x minus mu to the power of 2. By n, and for sample is s power 2. Then x minus x bar power 2, summation of that divided by n minus 1. Okay, let's just do this question and we'll see that better. Use mean and standard deviation to compare the distribution of the height for a 2 basketball team listed in a table 136. So this is the data that you have for this football teams, and here is the data. So to find the mean value, we just add all of these heights. It's 1155 and divide by the number. We have 7 data, so divide by 7. So 165 is mu. So here is x minus mu. 183 minus 165 is 18. 165 minus 165 is 0. 148 minus 165 is negative 70. So you do for all of this data to find x minus mu. And then x minus mu power 2, you just simply power 2. 18 to the power 2 is 3, 2, 4, 0 power 2 is 0, 17 power 2 is 2, 8, 9, and so on, we power 2. Now, why we do it? Because we want to do standard deviation using this formula. Then I'm going to sum that, right? Because this is x minus mu power 2 summation of that. So here I sum that, it's going to be 1520. So instead of that, I put 1520. And is how many data we have? Of course, it's 7 data. So square root of that will give you 14.7. So it's going to be a standard deviation is 14.7. The mean is 165 and the standard deviation is 14.7. Okay. So here we can use the technology to find the standard deviation as well. Here, when you have frequencies, basically you have an interval, you know, m is midpoint between the interval and f is the frequency. That would be the formula for a population and sampling. So finding the standard deviation of the population, standard deviation of the sampling. So now the next topic is quartile and the interquartile range. Okay, what is the quartile? If you have a data from the lowest to the highest, the median, we have median, right? 50% of your data is above the median, so 50% here. And 50% of the data will be below your median. Median, everyone knows how to find this middle data. Okay. So if you're talking about the quartile, we have Q1, Q2, Q2. Q1 means 25% of data is in first quartile, 25% of data is in your second quartile, and 25% of data is in your third quarter and 25% in the fourth quartile. See, if you add up, you have 100%. So it means Q1 is the midpoint between the median and the lowest. Q3 is the midpoint between the Q2 and the highest, the middle number, right? Now, interquartile range is Q3 minus Q1. So basically, this is your interquartile range, ICR. Interquartile range is Q3 minus Q1. So semi-interquartile range is half of that, basically just half of this. Now, what is a box and Wixter plot? So if you have data, we know the lowest, we know the highest. For the box, in this line, it indicates Q1, in this line is Q3, and here's median. We find these numbers and we put a box around that. Make sure you put a line on the median. And this is your risk, that you connect this to the highest and you connect that by a line to the lowest. So you need to be able to draw the box and whisker plot of your data. If you have an outlier, so make sure you're not including that in the whisker plot. So this is there. So if you want to find the outliers, when the data contain outliers, by convenience, any point that is at least 1.5 times the box length away from the box is classified as an outlier. And modify, so basically the distance between that and that, if you find 1.5 of interquartile range, and that's the distance between this outlier and the whisker. So if that distance is greater than 1.5 of the interquartile range, you consider that point to be outlier. So here we want to determine the outliers and interquartile ranges. Okay, so what we do, the data, you want to first determine the median, the first third quartile, and the interquartile and semi-interquartile range. Okay, so we need to write it down from the lowest to the highest. See? Here, it's 1, 2, 3, 3, 3, and we write it from the lowest is 1, the highest is 30. It means the range is 30 minus 1, so 29. So for median, it's a 20 data, right? So 20 plus 1 divided by 2 is equal to what? Is 10.5. 10.5 is between 10 and 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So these two 10th and 11th data. So 5 plus 6 divided by 2 is 5.5. This is going to be your median. Now, you want to find the Q1. Q1, you just look at that. Find the midpoint. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 plus 1 divided by 2 is 5. So fifth data. 1, 2, 3, 4, 5. So here, it's going to be Q1. So this is the Q2. Again, you do the same thing. We have 9 data, 9 plus 1 divided by 2 is 5. 1, 2, 3, 4, 5 here. So this is Q3. So we have Q1, 3, 3. We have Q3, 3, 10. Right? So interquartile range is Q3 minus Q1. 10 minus 3 is 7. Right? 7. So I would like to see if that 30 is really at the end, right? So let's just see. 30. 30, since the Q theory is 10, right? So just gonna go down here. Go. 30 minus 10. I want to find the distance of the 30 to this quartile, right? This one. 30 minus 10 is 20, okay? And what is the 1.5 multiplied by IQR? Is 1.5 multiplied by 7. It's 10.5. So the distance here, 20, is much more bigger than the distance is 0.5 of IQR. Much more bigger than 1.5 of IQR. That's why this is definitely an outlier. We can try it for 16 as well, but 16 is 6 away. So 6 is not gonna be, so it's 10.5. Of course, 6 is less than 10.5. So 16 is not gonna be, but 30 definitely is outlier because of this. So here is another one. In a survey, the lowest commute is the median is 7 points. So if you have a Whisker plot here, so in the middle one, you know, is 7.2. Q1 is 5.9. Q3 is 8.3. Here you have a lower end, and here is the higher end, right? We want to describe the following font. So it's XXY 7.5. 7.5 is here. So it's between, this is Q1, this is Q2, this is Q3. So this is first quartile, second, third quartile. So it's going to be the third quartile. Okay. So 9 going to be there. It's going to be in a fourth quartile. And 7.2 is exactly here. It's going to be on your median. Okay. So percentile. Percentile is the same as the quartile, but we divide this to the 100 intervals. Right, so let's just do this question. An audio magazine tested 60 different models. So this data, we have 60 models, and gave each one overall rating based on a sound quality, relativity, and efficiency. Raw score of this figures this in order. So this is in order from the lowest to the highest is good. Now, if the audio maximizes score at the 15th percentile, what was its raw score? So 50 percentile. So this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 30th is going to be 67. So 67. Let me really do that for you. 60, right? Plus 50% is going to be in the middle, kind of. 60 plus 1 divided by 2 is 30.5. 30.5 is between the 30th and 31st, right? So the 30th data is here and the 31st is here. Basically 67 plus 67 divided by 2, which is 67. So means my is 67 for 50 percentile. Okay. Okay, what is the 19th percentile? for 19 percentile, again, you can find, see, this is the 90% of your data is below what? 90% of your data is, have 60 data, it's 54, right? So 54 and 55. So here is 1, 2, 3, 4, 5. 30 data is here. Oh, actually, it's easy. So 60 is going to be 1, 2, 3, 4, 5, 6. So 54 is here and 55 of your data. So if you have 54 here, 54th and 55th, your data will be your 90th percentile, which is 90 and 80. And 75%, you know, see what it is. So it's 45th school, right? So 45, so it's 1, 2, 3, 4, 5, 30, 36, 40, 79, and 81. So 79 and 81, so the 75 for 15% is 80. Just taking the average, add 10 divided by 2, get 80. So therefore, for that, the score of 75 is below the 75th percentile. So since this is going to be 80, right? The 75 score going to be less than 75 percentile, below the 75. And the other things we have is a z-score. The z-score is a number of standard deviation that we can do it instead of the mean, right? So it's x minus mu divided by sigma. So how many standard deviation is your data is from your mean value? So there is x minus mu divided by sigma for the sample mean. So for sample, we have z-score to be equal to x minus x bar divided by s. So determine the z-score of the audio maximizer and the speakers. So knowing that this is 67, the mean value is 68.1 divided by the standard deviation. We can put that in a calculator. We can generate, we put this data, we can generate the standard deviation mean value, and then we will find for 67 data, what is the z-score. Okay, okay, for these questions, question number 1. Number 6. Here, question number 14th.